My dear AS students, in this video we go for another type of integration, which is integrating a binomial. You see here in brackets you have an expression including two terms, ax plus b to the power of n. First, before going for learning how to integrate this expression, I first would like to revise the definition of integration. Integration was actually anti-differentiation. Whatever differentiation does, integration does inversely. For example, look at this expression. Integration of 3x minus 6 to the power of 3x minus 1 to the power of 6. So now if you want to integrate this expression, it is producing this expression. But in other words, differentiation of this expression which I'm showing is to be this. Now let's check. When you differentiate this expression, power comes down, so 7 comes here. 7 and 7 cancel out each other. Then 1 is subtracted from the power, so the new power will be 6. Then the differentiation of interior expression comes out. What is differentiation of 3x minus 1? 3. 3 also comes out. So you have 3 out. You have this 7 as power out. And 1 is subtracted from the power. So 3 cancel out. 7 will cancel out each other. So the differentiation of this expression will be 3x minus 1 to the power of 6. Do you see here? Okay, now here, when n is a non-negative 1 number, why n cannot be negative 1? Because here the denominator will be 0. So integration of ax plus b to the power of n will be 1 over a. Why a? Because if you are going to, for example, differentiate this expression, you should obtain this expression. So when you differentiate this expression, a comes out. So a and a must cancel out each other because there is no a outside brackets here. Then n plus 1 also you have in denominator. Why? Because when you differentiate this expression, power comes down, then n plus 1 cancel out each other. As you see, there is no n plus 1 before brackets. So these elements will cancel out each other. Then ax plus b to the power of n plus 1 minus 1, which becomes n. So it will be exactly this. So integration of ax plus b to the power of n will be 1 over a n plus 1 ax plus b to the power of n plus 1. It is exactly what you did for x to the power of n. What did we do for x to the power of n? It would be x to the power of n plus 1 over n plus 1. So it is, for example, it is your expression. For example, u to the power of n plus 1 over n plus 1. But the difference is that 1 over a also comes out. Then plus a constant c. Now look at the example here. Integration of 2x minus 3 to the power of 4. So a is 2, n is 4. It will be 1 over a, which is 2, then n plus 1, which is 4 plus 1, 2x minus 3 to the power of 4 plus 1 plus a c. Then you simplify. Then here, 20. First, you should bring it up and write it as a negative index to the power of negative 6. 20 is the constant. Constant can be placed outside integration. Then it would be 1 minus 4x to the power of minus 6 plus 1. N is minus 6. So n plus 1 is here. And what is a here? A is negative 4. A is negative 4. A is coefficient of x, which is negative 4, is here. Then you simplify. Now let's go for the third case. It will be 5 2x plus 7 to the power of negative 1 over 2. Do you see? 5. 5 is a constant. You can write it outside. So it will be 5. Integration of 2x plus 7 to the power of negative 1 over 2. Then your n is negative 1 over 2. And what is your a? A here is 2. So it will be 1 over a. It is 1 over a. 5 is the constant outside. You put it back. Then n plus 1 minus 1 over 2 plus 1. Then 2x plus 7 to the power of n plus 1 plus a c.